Good day, this is MCH 101, General Mathematics 1. I will be taking you through study section 13, Parametric Equations of a Cycle. Learning outcomes for study section 13. After you've studied this study section, this slide, you'll be able to state the parameter equation on a given cycle. You will be able to solve some problems on the parametric equations of a cycle given the general equation of the cycle. And lastly, you will be able to determine the center and the radius of the given cycle with the parametric equation. In mathematics, parametric equations are a method of defining a relation using parameters. A simple kinematical example is when one uses a time parameter to define the position, velocity, and other information about a body in motion. Abstractly, a parametric equation defines a relation as a set of equations. It is therefore somewhat more accurately defined as a parametric representation. So what we are saying is that we use a set of equations to define a relation, and it is a part of regular parametric representation. Let us continue as we consider a cycle with center C and radius R, and let P be any point on the cycle. Now let's consider this axis, X and Y. This is Y axis and this X axis. And let's consider a cycle with an angle let this be the point P and the angle, and let this be our center, and let this be Q. Now, these are points. Point P is any point on the circle which is represented by XY, and C is represented by A, B. Now, if you can recall, in our previous study section, we were introduced to how you can obtain the side of a triangle, especially a right angle triangle using your SOHCAHTOA. And if you want to obtain the vertical component from this cycle on the presentation, you will use the relation sin theta is equal to PQ all over R. Now, R is the radius, and from that you can obtain your vertical component. The PQ will be equals to R sin theta. Similarly, you can obtain your horizontal component, which is your PC. And if you want to do that, you know that your cos theta is equal to QC all over R. Do not forget that our R is the radius, and QC, making QC the subject of formula will be equal to R cos theta. These are the horizontal and the vertical components of this cycle. Let's go back to our slide. As I said earlier on, we can see from the above figure, the horizontal component we obtain as QC is equal to R cos theta, and similarly we obtain the vertical component, which is PQ is equal to R sin theta. So the point P on the cycle, as we were shown before this slide, is the coordinates, and is given by two equations, which is X is equal to A plus R cos theta, and Y is equal to B plus sin cos theta. And these are the parametric equation that we obtain. And let's try an example. But before that, okay, let's go to an example. Example 1. Find the parametric form of the equations of a circle with radius 3 and center 7, 5. Now, how do we obtain the parametric equation of in this kind of problem? You know, we're given that r is equal to 3 and we're given this point 7, 5. From this, you know that your a is equal to 7 while your b is equal to 5. Now, substituting all these values into the parametric equation, do not forget that we say our x is equal to a plus r sine theta, while your y is equal to b plus r cos theta. So if you substitute all this into this parametric equation, you obtain your x to be a, which is 7, plus, do not forget that your radius is 3 sine theta, while your y will be b, your b is your 5 plus 3 cos theta. So you have obtained your parametric equations. Now let's go back to the slide to solve other examples. So that was how we obtained our parametric equation. What about a situation where you are asked to determine the center and radius of a circle given a parametric equation of the circle? In order to find this, the center and the radius of the circle, which equation is given in the slide, you have to compare this equation with the general equation of a circle, and we are going to do that now. Now, in order to find your G, your F, your C, you have to compare the given equation with the general equation of the circle, which is given below, which is your x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And how do you do that? You are going to arrange this given equation in form of your general equation of the circle. Now let's continue and work that out. X squared plus y squared minus 4x plus 6y is equal to plus 12 is equal to 0. And comparing it with this equation, then you'll be able to arrive at the value for your g. Your g, 2gx is equal to minus 4x. Now, if you want to obtain your x, you divide both sides by x, and you get 2g is equal to minus 4. Then you divide through by 2, you obtain your g to be minus 2. Similarly, if you want to obtain your value for f, what you will do is to compare this two components. That is 2fy is equal to 6y. If you divide both sides by y, then you eliminate y. You have 2f is equal to 6. Dividing both sides by 2, you obtain your f to be 3. Also, similarly, you know that your c, which is your constant, is equal to 12. So you have obtained different values for g, f, and c respectively. Since we have obtained all we have obtained the g, the f, let us see how we are going to obtain our center. And the formula for center is given as minus g and what? And minus c. So what we are going to do is to substitute for what we got for g and what we got for c. Do not forget for our g we obtained minus 2, and for our c we obtained 12. So if you substitute these two into the this formula, you have minus into minus 2, comma minus into 12. So at the end of the day, you arrive at 2, comma minus 12. So that's your center. Now, what about radius? It is very important for us to calculate the radius. So, and how are we going to do that? Now, there's a formula you use to calculate your radius. Your radius is equal to square root of your g squared plus f squared minus c. That is your expression for radius. So how are you going to do that? All you need to do is to substitute all these values into the formula, into the expression. And so you substitute all this into the formula, your g. Do not forget that our g is minus 2 squared plus our f, we got 3 squared minus c, which will appear to be 12. So what you are going to do is to expand this to find the corresponding value for all the values. This will be 4 plus 9 minus 12. And we know that 4 plus 9 is, 4 plus 9 is going to be, if you bring this here, 4 plus 9 is 13, 13 minus 12. That's your radius. So that is the square root of 1, then your radius is going to be 1. So thanks for listening.